So here's a chance for you to check your answers. So the log base 10 of 100 is 2. Now remember that the log base 10 is also called the common log. And so if we don't see a base, it's assumed to have a base 10. Log base 5 of 1/125th is -3, so that means 5 to the negative 100, or excuse me, 5 to the negative 3 is 1 divided by 125. The log base 27 of 3 equals 1/3, which means 27 to the 1/3 equals 3. And then the log of 1,000 equals 3, because remember, if you don't see a base written, it's a base 10. So our solution is 10 to the 3rd equals 1,000. Now we know that a logarithm is most closely understood as being related to an exponential equation. In fact, whenever we get stuck in the problems that follow, we might return to this one simple insight. We might even state a simple rule. So the question is here, we're going to graph an exponential function. So there's our graph of the exponential function, and they want us to find the inverse of that function. Now remember, when you find the inverse, you switch your x's and y's. And then you solve for y. Well, the only way I can get this to equal y is if I use a logarithm. Because remember, logarithms equal the exponents. So that means that y equals the log base 2 of x. So when we do the inverse, we're going to switch our ordered pairs. So instead of that being 1, 1, it's going to be 1, 1. I'm sorry. Instead of that being 1, 2, it's going to be 2, 1. And instead of that being 2, 4, it's going to be 4, 2. So you can see that those ordered pairs swapped. So we had the ordered pair of 1, 2, and it became 2, 1. We had the ordered pair of 0, 1, and it became 1, 0. So our logarithm. So when you think about this, you can think about domain and range as well. Because as you're looking at the exponential function, we know the exponential function has a domain of all reals, but its range is greater than 0. So when we do the inverse, it's going to be the reverse. So we're going to have our domain would be greater than 0, but our range would be all reals. So you can see how those points played out there, and we just plotted the inverse points. So I want to go back here and just specify, before this comes up again, what our domain was. So for our exponential functions, when we had exponential, our domain was all reals, and our range was y is greater than 0. So when we do the inverse for the logarithmic function, our domain is greater than 0, and our range is all reals. Because you can see this starts down here and goes all the way up, it never stops. So that's the inverse. So likewise, you could say that y equals 10 to the x is the inverse. It's a terrible looking inverse of log of x equals y. Okay? So what they're asking us to do here is to actually calculate some things. So if you want to think of it in terms of exponentials, you can, or if you just want to think of it in whatever. So when it says here the log base 8 of 64, well, that means 8 to some power equals 64. Well, that's 8 to the second, right? So here we have the log base 7 to some power equals 7. Well, that's 1. The log base 6 of 6, so that means 6 to some power equals 6. So that's 1. Then we have the log base 5 of 1 equals some number. So that means 5 to some power equals 1. we got our zero exponent property. Here we have 4 to some power equals 1/4. Well, since the 4 is in the denominator, we could write that as 4 to the negative 1. So our exponent is negative 1. And here we have 3 to some power equals 1/9. 9 is 3 squared, so I could write that as 1 over 3 squared. And then since it's in the denominator, I could write it as 3 to the negative 2, so I've got my negative 2. So that's just using the properties of logs and what you know about exponents. So here it wants you to state the inverse of the function with the given equation. So if we're going to find the inverse, we have to switch our x and y. So it starts out with y equals 10 log x. So we're going to switch this to x equals 10 log y. Well, in order to do this, I want to get it so it just has the log here. So I'm going to divide by 10. So I have x divided by 10 equals the log of y. Well, when I do this, what's the base if I don't see a number? It's 10. So that means 10 to the power, which is x over 10, equals my number. So that would be 10 to the x over 10 equals y. Likewise here, we do the same thing. Y equals the log base 5 of x means x equals the log base 5 of y. So if I follow my definition, 5 to the x equals y. So now this one is asking you to think a little bit. The log of some number is 3.456. So that means that k has to be between what two numbers? So that means that this number right here has to have an exponent, right? Because the power, the property here, this is our power. So our power is something to that power. Well, if this is base 10, that means that number has to be 10 to the 3.456. So what numbers is that between? Is that between 1 and 4? No. 10 to the third is not between 1 and 4. It's at least 10,000, right? Or it's at least 1,000. So boom. Because 10 to the third is 1,000 and 10 to the fourth. So it's between those two numbers. Because 10 to the third would equal 1,000, and 10 to the fourth would be 10,000, which is a one with 4 zeros. So since it's 3.456, the number has to be somewhere between those two. And then we're going to write the equivalence. So this is going to be the log base 4 of 1024 equals 5. The log base 5 of q equals p. 3 to the 7th equals 2187. 9 to the n equals m. Now, this goes back to what the log function looked like. Well, our log function normally would intersect at 1, 0. Right? This one does not intersect at 1, 0. This intersects at 3, 0. So we moved our graph 2. So we went right 2. Which of these equations shows the graph moving right 2? Now, if you're not sure, you can type these in your calculator. When you look at the first one, it looks like it's going right 2, but when you type that in, you've got the log of x plus 2. It actually moves it up 2 units, so that's not it. This says log of x minus 2, and remember, when we've got the x's, it's the opposite of what we see. So this would actually be choice B. Okay? And then this closure I will put as an assignment on It's Learning for you to do. Okay? Thanks, guys.